UVs can be quite an intimidating concept when you first start 3D. They're one of those technical speed bumps that we find a lot in 3D, and unfortunately they gatekeep our ability to texture our 3D models. This can be one of the most rewarding things about 3D, so hopefully by the end of this video you have a better concept of what UVs are and how you can utilize them. U and V literally just stand for the two axes in the 2D UV space. Just like in 3D, we have X, Y, Z as our axes. In the UV space, we have U, our horizontal axes, and V, our vertical axes. Now this 2D UV space exists so that we can map our 3D objects into a 2D space so that we can apply 2D textures. As of now, this is still the main way we apply 2D textures. In most games, most films, it's still going to be a UV unwrap and then texture in a 2D space. Just like a lot of other areas of 3D, there's plenty of different ways to UV unwrap and so many different tools that we could use, but the same principles apply. Let's have a look at the basic concept of UVs on this animation of a cube. We start with a 3D object and we actually apply a series of cuts along the edges in the UV space. The aim is to cut enough edges that we can flatten the object down into pretty much 2D, kind of like cutting a box to put in the recycling bin. You can see here with the cuts applied, the cube has now unfolded into this 2D shape. This shape now acts as our UV map, which is ready to take a 2D texture. If this UV map has been done correctly, if we fold the 2D object back up into a 3D object, we should see the 2D texture has been applied quite effectively. Let's have a look at this now in a 3D program. I'm using Maya here, but the same concept would apply in any 3D software. The UV space is represented on the left here, and the 3D space is on the right. You'll notice when I hover over any component in the 3D space, an equivalent component will be highlighted in the UV space, and vice versa. This is essentially the main concept of UVs. We want every part of our 3D object to be represented in the 2D space of the UVs so that it can take 2D texture and apply it back to the 3D space. Now what gets confusing is changes made in the 3D space or the UV space won't necessarily affect the other space. The main idea we've got to get our head around here is whatever the shape and scale of the things are on the left in the UV space, it's going to be transformed into the shapes that we have in the 3D world. This can of course be manipulated in lots of different ways. You can see here we can even separate different components off, even so they're still attached in the 3D space, and you can scale them up and you can distort them. But for the most part, we're going to try and keep this simple and keep it all together. So let's now have a look at going through the whole process, pretty much what we saw in the animation, but what it looks like in the software. Since a lot of what we see won't have visual feedback, I'm going to have this real life box as well to visualize some of the concepts as we go through this unwrapping process. I'm going to start by just making a cube similar size to the box I have. One super important thing whenever we unwrap anything is to make sure we've frozen our transforms, especially scale. If we have uneven scale, like you can see here, we're going to get disproportionate UV shapes in the UV space. So make sure we always freeze transforms, and I guess usually deleting history won't hurt as well. I'm going to open up my UV editor at the top, UV editor. This is going to show me my UV space as well as this UV toolkit, which pretty much has all the tools we're going to need today to do some basic UV unwrapping and mapping. There's always going to be exceptions, but 95% of the time, your goal with UV unwrapping an object is for the entirety of the 3D object's surface area to be evenly and accurately represented in the UV space. This comes with probably the most important thing about UV unwrapping is that we want little to no distortion of the texture when it gets applied to the 3D object. We can actually see some distortion straight away here using Maya's test texture, which we can turn on and off at the top of our UV editor. It's pretty much just applying a bunch of squares, and if we don't see squares on the 3D object at the end, something's getting a little distorted. The reason it's happening here is because the UV unwrap we have at the moment was meant for the cube primitive. Because we've scaled it out slightly and made it more of a rectangular prism, the UVs aren't accurately depicting the surface area of the 3D object. Now we could reuse the cuts it's already given us and probably fix the distortion pretty easily. But to demonstrate, we're actually going to start completely from fresh here, get rid of all the UV cuts, and go through the process of deciding how we can get our own flattened shape into our UV area here. We're going to start by wiping all the cuts by applying a new kind of UV projection here. These are pretty much ways to start UVs. There is automatics, which you can use, but for now what we're going to use is camera based. You'll see the result here. It kind of looks like a 3D object. These are actually used in their entirety in films if you've got background objects, because the camera never goes around the back, so you don't really need to bother texturing from different angles. The only reason we're using it here, because it got rid of all the cuts, and now we can start fresh and put our own cuts in. Most programs are going to have a bunch of different tools to do UV cuts. We're going to keep it really simple here and just click on the edges we want to cut and then select the cut tool inside our toolkit. So I'm just going to grab these two for now and just show you something. Inside cut and sew here, we find the cut button. We're going to click it and you'll see these edges now become kind of bold, and they'll be white if you're not selected on them. Now remember, these are only cut in the UV space. There's no actual separation happening in the 3D space. These edges here are going to behave exactly the same as they did before. In the UV space now though, they are technically separated. So we can actually change to UV shell mode or select the objects. And what we can do now is pretty much try and see if we put enough cuts in. So we're going to go to unfold here and click unfold. And this is going to apply a simulation to the object of what might happen if we try to flatten it with the amount of cuts we have at the moment. As you can see, it's a bit of a mess, and we might as well have just stepped on it. As you can imagine, a shape like this really isn't going to take texture very well. And we can visualize this already by turning on our test texture. And like we said before, we're expecting to see squares, and we're just seeing a huge mess here. This is exactly what will happen to your texture if you try to apply it to the 3D object. So it clearly doesn't work. What we need to do is just add more cuts. One thing that's nice about UVs is they're quite non-destructive. So we don't even have to clean up our horrible mess here on the left. We can just add more cuts and try the unfold again, and it'll clean up for us. So what we're going to do now is just use our brains a little bit. We're going to think about the object we have and think about which edges we can cut so that it can unfold to be a flat object. So it should be pretty simple. We just got to think about how these tabs in the sides can kind of fall down and then flatten out after we've cut everything. Another concept you might like is, I like to think of it as backwards origami. So we have the 3D object and we're trying to make the piece of paper. So think about where you need to cut for that to happen. Once you put all the necessary cuts in, all we need to do is just try apply that unfold simulation again. Remember, it's non-destructive, so you can press this at any point. So we're going to click it and we should get a pretty nice result. And if you have a look on the right, it's exactly how it looks like in real life as well. So we know that that's how it should work. We know that that's a flat object and it will take texture really, really nicely. Once we've finished with our unfold, we have a few more things we just want to clean up if we want to use this as a UV map to apply texture to. Something you should always try to do is straighten your UVs as much as possible. We can actually find a button in the toolkit here called Orient Shells, which usually does a pretty good job if it's a square UV. Something you may have noticed is the UV space is infinite, just like the 3D space. Most of the time, we're only going to use this initial square here. So if you look at the little values on the graph, it only goes up to 1 on U and 1 on V as well. There is times where we use other squares on the UV space. This is a little more advanced, things called UDIMs and such. But for now, everything you do will probably just fit inside this initial square. So looking at the dark gray lines, you can see I've just fit my UV shell into this initial square. This unwrap is pretty much complete and it's ready to take texture. I could export it out and texture it in another program, but for now I'm just going to apply this foliage texture here just to make sure that it all looks correct, which it does. You'll see the texture gets split up by the seams or where we put the cuts in. This is something to be aware of, and we'll explore a little bit more of that in a second with some extra examples. Let's now just have a look at a more complex object unwrap and talk about where automatic can be useful and why it's important we do understand this more manual process so we can see what's happening and how UVs may affect a texture. Let's unwrap this more complex object here so I can highlight a few extra points. First thing you'll notice is it's got the same UVs as a cube. That's because we used a cube primitive to create this object, but as soon as we model anything extra, the UV is not constantly being updated. So whenever you get to UVs, you are going to have to start fresh in some way. Of course, you can use automatic, which we'll go over soon, but either way, you're going to have to kind of restart the UV process. It's not going to give you anything for free. I'm going to breeze through pretty quickly the unwrapping process of this. It's going to start the same way we did the cube before. So we're going to start with a camera-based projection to wipe away all the cuts, and then we're going to add our own. The main difference with this object is we're not going to be able to keep it all together in one UV shell this time. So what I'm going to do instead is just really separate all the pieces out and actually keep it simple for myself. These days, with most texturing being done in 3D texture programs, keeping faces together is not really that important anymore. We don't have to read the UVs as much to know what we're texturing, but obviously there's still some benefits, so you just got to find a bit of a middle ground. There's of course a bunch of exceptions and different times you want cuts in certain places. There even is things like having cuts on every single hard edge is something that we need when we're baking high poly into low poly, due to the fact of how normals works, but that's a bit more advanced. As you can see now, I've split up my object in the UV space into 4 different UV shells. I can be in UV shell mode by holding right click, and now all I want to do is essentially take all of these and see if I can unfold them. So I've cut them up and I've cut them into separate pieces. Now each one I can click on, click the unfold simulation and see if it gives me a good result. Here's a good example of one that does not go well. As you can see, I'm getting a bunch of distortion, so it just means I probably missed a cut or two. I can kind of read on the left that it's kind of all collapsing into itself, and that's because it's pretty much a full ring I've left open. Just by splitting it up twice here, you can see now when I unfold it, it comes out nice and flat, just like a little ribbon. Now with all my UV shells unfolded and accurately depicting the texture without any distortion, the last thing to do is the same thing we did before. We want to orient them and then keep them in that little square in the middle. Now after we orient them, we could manually place them into that 1x1 square in the middle, but this will arise a little problem. As you can see here, my 2 objects or my 2 UV shells that are the same size in the 3D space are different sizes in the UV space. This is due to the fact that they have different Texel density. This just comes from the initial camera projection, as it's given these UV shells slightly different sizes in the UV space. It's something we can fix, but Texel density essentially just means how much texture in this space on the 3D object. So pretty much how much that face or area on the 3D object is taking up in the UV space. So we can see on the back side, there is a lot higher detailed texture. On this front side, it's a lot lower. We can actually see the number itself in the transform section of the UV toolkit, where we can actually get and set the Texel density here. This is kind of the manual way to fix it. Most of the time we want this to be the same for all our faces and areas on the 3D object. Just like everything else, there of course is exceptions. Sometimes you would like higher Texel density in things like a face or a sign where you need higher texture detail, and you can get away with less on other parts of the object. The easiest way to fix this and to kind of get the finished result is to just use the layout button. So we're going to select all the UV shells here, or we could grab the object, and we're just going to go right down to the bottom, arrange a layout, and click layout. We can do some more accurate layouts with the settings, but for now, it's just a demo of the kind of process. This again would finalize this object, and it's now complete in its UV unwrap, ready for texture. Last thing I want to talk about real quick is when to use automatic and when maybe not to use automatic. Pretty much I would say use it as much as you can. As you can see, just doing it on that complex object gives us a very similar result, and there's absolutely nothing wrong with this UV unwrap. I've got another video on the process of automatic unwrap, so I'm just going to kind of skip that for now. Where automatic unwrap can kind of fall apart is organic shapes. So as you can see here, it kind of struggles a bit on the top here of the dome section. It's put these kind of really zigzaggy sort of patterns in, and we kind of want to avoid those most of the time. Now the reason for this is it's usually trying to avoid distortion more than anything. When it comes to organic shapes, usually as an artist, you're okay with a bit of distortion because it'll give you a lot nicer UVs to work with. As you can see, doing a manual approach here, I can simplify the UV unwrap quite a bit, where I just cut the dome off the top. And of course you will get some distortion because it's like trying to squash down this dome. But because it's already a rounded shape, it's rounded distortion anyway. So it's going to be hardly noticeable. Where you see on the automatic unwrap, it's going to put that zigzag and there's distortion there anyway. So we might as well just keep this free for when we texture it. Just jumping into Substance Painter here to have a quick look at what these seams look like in a texture process. As you can see, automatic stuff here is going to highlight the seams a bit more than anything, but even if you're manually painting, sometimes it can be unavoidable to hide this completely. So you've always got to have this weird balance of saving time as well as trying to get the least amount of distortion with the least amount of work as well. So hopefully UVs are a little less scary now and you can kind of understand the whole idea. I would say key takeaways from this video is when you're starting, the main thing you're looking to get rid of is distortion. Make sure every piece of your 3D object is represented in the UV space. There's no stretching that's going to appear on the texture, and the rest is really case by case. So get those main two concepts down and you'll be able to put some beautiful textures on all your 3D models.